Alright, these are on special factorizations, and I'll try and do one of each type. And so this is the first type, and this is our difference of squares. Okay, we call them squares and difference of squares because difference comes from the minus sign that's in the middle, and the squares comes from the fact that 100x squared is equivalent to something that is squared, and that something is 10x. And also because y squared comes from a y that is squared. So the 100x squared comes from a 10x squared, and y squared comes from a y squared. That pause in between y squared kind of implies parentheses around it. Okay, and in fact our first step in all of these problems is going to be to rewrite them so that they fit the model a little bit better. I'm going to rewrite this entire problem as just 10x squared, which we know is 100x squared, and I'll rewrite it as a y quantity squared. So this line at the top and this line are exactly equivalent to each other, but I've written them in this new form because the model for factoring these is written as something squared minus something squared. And now my something is 10x and my something is y. And the formula says break it up as a minus b times a plus b. So that's the factorization for the difference of two squares. And I can see that for me a is 10x and b is y. And so jamming it into this model, I am going to let me erase that and just continue down with the green because it isn't equivalent to this pink. What I get when I use the model is a, which is 10x, minus b, which is y, times a, which is 10x, plus b, which is y. And so there is the solution, or the factorization I should say, to the original question, how does 10x squared minus y squared factor? It factors as 10x minus y times 10x plus y.